one is through a process called elimination. This video is on substitution. I think the first thing we want to make sure we understand is that when we are solving linear systems, and let's just put an example over here, we'll say 2x plus 5y equals 7, and x plus 4y equals 2. These are graphs of lines. Both of these are graphs of lines. Now I'm not going to graph these lines for you, but when we say we're going to solve this linear system, we're looking for a coordinate, an xy coordinate, that represents the intersection of these two lines. So just hypothetically, if this was one of those lines that we have here, and here's a second line that we have here, the point of intersection where those two lines meet, okay, that's the point x comma y that we're solving for. And we could do it graphically. I could ask you to graph these lines and you'll see that point, but we're focusing right now on solving these algebraically. And remember that if we get a solution xy, that's the intersection. If we get no solution, that means the lines don't intersect, and that means the lines are parallel. And if we get infinite solutions, it means that the two lines, although the equations look different, are essentially the same line, in which case there's an infinite number of intersecting points. So again, we're solving for that intersection, and there's two ways to do it, substitution being one. So we'll take this problem, and here's how you substitute. Look for the term, either this one, this one, this one, and this one. You first look for the term where the coefficient is 1. Okay, this has a coefficient of 2, this is a coefficient of 5, this is a coefficient of 4, here's a coefficient of 1. When we have that, it means it's a good candidate for substitution. What we do is, we'll call this here equation A, and we'll call this here equation B. We'll take equation B, okay, which is x plus 4y equals to 2. And we'll rewrite it as x equals. In this case, x equals. In a different problem, it could be y equals, if the y term happened to be the term with the coefficient of 1. But in this example, it's the x term, this one right here, that has the coefficient of 1. And we use algebra, and we solve for that x term. And I'm just moving the 4y to the other side by subtracting it from both sides. So now we basically take the B equation, and we turn it into that. And what we do is we take that and we substitute it into the A equation. And the way we do that is, in the A equation, we start writing it. It's 2x, but instead of writing x, we now know that x is 2 minus 4y. We're going to substitute in this x into this A equation. So we do that. And then we continue with the equation. So this equation is 2x plus 5y equals 7. It's just 2x plus 5y equals 7. But instead of writing x, we put this in its place. And then we just use our algebra. We distribute the 2. 4 minus 8y plus 5y equals 7. Negative 8y, positive 5y is minus 3y. We bring the 4 over to the other side. We get negative 3y equals 3. And we get y equals negative 1. Once we solve for one variable, in this case y, we plug that back in to any of the original equations. We could pick this one, we could pick this one, and this one is the B equation just rewritten. And this is always the easiest one to go back to, because by virtue of the fact that we described equation B as x equals 2 minus 4y, well, we need to solve for x. And x equals 2 minus 4, but we're not going to write y, we'll write y we just solved for. So x equals 2 plus 4, which is 6. Okay? So for this problem, the solution is going to be x equals 6 and y equals negative 1. And that basically means that if I graph these two lines, they would intersect at the point 6, negative 1. Okay, let's do one more just to make sure we've got that. Let's go with 3x plus 2y equals 6, and x minus 4y equals negative 12. Look for the coefficient of 1. It's not that one, it's not that one. Here it is. So we take this equation and we rewrite it. Okay? substitute that back into the first equation. So we have 3x, but we're not writing x, plus 2y equals 6. So 3x plus 2y is 6. 3x plus 2y is 6. Okay, we distribute. We combine like terms. And we get y equals 3. Okay, then we come back to this equation, solve for x. Okay. So our final answer in this problem is x is 0 and y is 3. So for using substitution, we've just determined that these two lines intersect at the point 0, 3. So that's how you do substitution. Good luck.